So we're going to talk through how to improper integrals. So first of all, what is an improper integral? Well, an improper integral is if we're trying to integrate something between 2 points, B and A, and it's some function. Okay, so this is like the general form. And we want to find out the value of that, except there's a problem with B and A. Okay, so this would be improper. So this integral would be improper if. Okay, so sometimes it asks you why the thing you're trying to integrate is an improper integral. Okay, so let's go over the conditions. So one would be that the interval of integration is infinite. What do I mean by that?
Is that like when we're getting B into
Yeah, i.e. if A equals infinity or negative infinity, so let's put plus or minus infinity in there, or B equals plus or minus infinity, or negative, yeah. Okay, so sometimes before it asks you to do the integration, it will say, why is this thing an improper integral? So if either of the limits are infinity, you'll say, because the interval you're trying to integrate over is infinitely large. Okay. Another reason might be that the function you're trying to integrate, whatever f of x is not defined at A or B. Would you like me to give you an example of that? Yeah. Okay. So e.g., let's say the function, let's say A equals 0, for example, and the function you're trying to integrate is 1 over x. Okay, so it's not defined when x is A, which is 0. You see what I mean? Okay. So if by putting in one of the limits into the thing you're trying to integrate, you get something stupid, something undefined. And
so is that where the thing you're trying to integrate can't be also when it's being integrated? So like, sorry, so if the integration was 1 over x dx.
Yeah. Let's just take this a little bit further, yeah? We're trying to integrate 1 over x. What does the graph of that look like? Looks something like this. It tails off like that. So the b value, what I'm integrating up to here, could be anything, yeah? But if I wanted to integrate from a equals 0 to say b equals 2, well, there's no value really. It goes off to infinity there. It's undefined at this point here. Okay. So really, looking at it, it's hard to tell what the area under that curve would be because it just keeps going to infinity. So, okay. So, so the second reason it might be improper is that one of the limits on the integral is undefined for the function. There's no value there or something like that. Okay, it's undefined value. And then the third reason might be a similar sort of idea really, that the function you're trying to integrate is undefined between A and B. Understand what I mean by that?
Is that like when it snaps? goes off.
Might be an asymptote between those values. So if I try and integrate and find the area in between those values, there's a point where there's a discontinuity in the middle somewhere. Okay.
So basically, you can't integrate it when the area is technically infinite.
Yeah, but we might find we might find that when we integrate it, it's not actually infinite. Okay, but just looking at it, we can't integrate things that are not continuous. Okay, or we can't integrate over an infinite area, over an infinite distance, which is the first condition. Okay, so if you're asked why something is improper, those are the conditions, right? Okay. That before we start doing the integrations and how you set it out, there's two other things that you need to be aware of. Okay, so that's the first thing. And the second thing that is going to come into these questions are just two results that you need to be aware of. Okay, so things to remember. These aren't in the formula book, so they are literally things to remember.
Do you want to pause it?
No, it's okay. I was going to do it a different way around, but we'll do it like this. So these are results that you need to know. Okay. When x goes to infinity, in this particular type of expression, so I've got x to the k, e to the minus x. If you ever see that, x to the k, e to the minus x, and x tends towards infinity, so I'm saying what happens when x gets really big, this thing heads towards 0 for any k. Real. Okay. So if you ever see, when you do your integration, this is the point really, when you do your integration, one of the terms in your integration is x to the power of something, e to the power of minus x, and you're trying to work out what happens when x gets very big, that particular thing gets very small. Okay. Okay. And then there's just another one like that for you to remember, okay? Which is, why is that in some sort of way? When x goes to 0, x to the k, again for any real k, ln x, this one tends towards 0 as well. That's for all k which are greater than 0. So you need to just remember those two things, because if they pop up when you do your integrations and you get something like that, you need to be aware how they behave. Is that alright? So what we're going to do is, I think we'll just do some examples rather than best to do it by example, I think. Okay, so we'll do an example of an improper integral, and then I'll talk you through the method, and the method's pretty much the same every time. Okay. Okay, so I'll do another example. Trying to integrate between infinity and 1 over x minus 2 over 2x plus 1. Okay. Right, is that an improper integral?
Yeah.
Why? Because
one of the integrals is
we're integrating over an infinite interval, yeah? So what do I do instead? What am I writing here?
limit
Yeah.
as a tends towards infinity.
Yeah.
The integration between a and 1.
The integration between a and 1, yeah, of all of this, yeah. Brilliant. Okay. It's just all about how you set it out, really, because the actual integration you're doing is the same as, like I was just saying to Daz, it's just like a C3 or C4. So we'll keep that limit in front. And we've got to try and integrate this then. 1 over x, what does that integrate to? Yeah. And this one? Minus, yeah. The top is the differentiation of the bottom, so it's 2x plus 1, yeah. Excellent. Okay, and I'm going to sub in a and 1. Yeah?
Yep.
Okay, keep this written like this. Oh, I'll underline it. So I'm going to sub in the a, so I'm going to get ln a, take away ln 2a plus 1, and I'm going to take away, I'm going to sub in 1, so it's going to be minus ln 1 plus ln 3, is that, yeah? You okay with all that?
Yep.
Right, can I do anything with these luns now?
I can do ln a over 2a plus 1 over 1, can't you?
What's ln 1 first of all? It's ln 1.
0.
0, yeah. So this one's going to go, the ln 1's going to go, I'm going to get ln a, well I can combine, the point is I can combine them all into one ln, right? It's going to be ln a over 2a plus 1 multiplied by 3. So let me write it out and just check that you agree. The ln 3 and the ln, that's going to be 3a on the top. Yeah. So that all gets combined into that. And now I want to start thinking about what happens now as a goes to infinity. What am we going to get? There's two ways of thinking about this last little step. But
well, because as a goes to infinity,
yeah,
the bottom gets really, really big, so just the top.
Yeah, which one?
Just transfer.
Well, one way you can do it. I'm just talking about this ln of this, right? Okay, ln of this. It's a fraction, and if you're trying to work out what's happening when a goes to infinity, take the top and the bottom, divide them both by a. I can do the same to the top and the bottom. It doesn't change it as a fraction, does it? Okay, so I'm going to divide top and bottom by a. By a, top and bottom. So, what does that give me?
3 over 2 plus
3 over 2 plus 1 over a. Okay, and I'm going to ask you the same question, okay? What happens when a goes to infinity? Ln 3 over 2, yeah. Okay, that's it. Now the other way you could have thought about it was, yeah, you've got you'll have 3 lots of infinity over, I mean, it's probably not the best way of thinking about it. As a gets bigger, in this fraction here, that plus 1 on the bottom, let's say a goes to 1,000,000, Charlie, yeah? I'm going to get 3,000,000 divided by 2,000,000 plus 1. That plus 1 doesn't really have no. Yeah. But it would be 3,000,000 over 2,000,000, right? Okay. So you can see it's the same idea, right? I want to do one more example, but I want to do one where we have to use that result. So shall I pause it and I'll try and find proper, yeah? Why?
Root x can't be 0, that's possible.
So it's the 0 on the bottom.
Find it 0.
So we're going to let A tend towards 0, yeah? Put the A on the bottom. Now this one's going to be a little bit harder to integrate, as you can probably see. Yeah? So, let me just write it out one more way. This is a product of two functions, do you agree? This is 1 over root x times ln x, yeah? I'm just going to write it like that so you can see it's 2.
Yeah.
Okay, so integrating products. I'm going to integrate products.
U equals ln x.
Why do I want u to be ln x?
Aren't you going to use product rule?
I'm going to use product rule, yeah. So one of them's got to be u and one's going to...
It's priority, I thought. Because when you differentiate it with 1 over x, isn't it?
Can I integrate ln x easily?
No.
Not as easily as differentiating it, right?
Like I said, I remember there's a priority.
Okay. So we're going to let u equal ln x, yeah? So u dash,
Right.
yeah. Okay. And we're going to let v dash then be so 1 over root x, yeah. So if I integrate that?
2x to the power of half.
Yeah. 2 root x, yeah.
Yeah.
Okay. So let's try and do this integration. Oh, it's come down. Oh, what's happened? So we're trying to integrate between e and a, the limit when a goes to 0, ln x over root x dx. And we're saying that should be the same as ln x u times v, so that's 2 root x ln x, yeah? I've got to remember to put in the e and the a into there. Okay. Sorry, Charlie. I've got to be really careful with the notation here. The limit when a goes to 0 and that is the same as the limit when a goes to 0 in. Then I was doing the same thing, yeah. So this is 2 root x ln x. I've got to put in the e and the a, yeah. Minus the integration.
You need to put the e and the a, don't you?
Yeah, no, I've still got to sub the e and the a into there, yeah.
Yeah, but can't you put it at the complete end?
No, because there's an integration here, yeah. And then it's going to be du dv, right? Sorry, du v. Yeah? So this is going to be 2 x to the half times x to the minus 1. So is that x to the minus a half? Yeah? So let me just write this slightly different. Take the 2 out, side as a coefficient. This is 1 over root x, isn't it? And we've already integrated that over here, haven't we? Okay, so we already know what the answer should be. Okay? So let's just go through all of this and see what we get. Oh. Okay, so we'll just write it out again. This thing we're trying to integrate. A ln x over root x dx should be equal to the limit when a goes to 0. Right, let's start thinking about this. Let's sub in the e. Okay, I'll sub in the e. I get 2 root e ln e. Yeah? You see what I'm doing here?
Yeah.
I'm going to sub in the a. 2 root a ln a. Yeah. And now I'm going to do the integration of 1 over root x. Well, you've already done it, haven't you?
Yeah.
When you integrated 1 over root x, we got 2 root x. Yeah? So this is going to be minus 4 root x, right? Keep moving around, so from just up here, that's going to go to minus 4 root x, yeah? Do you agree? So this is minus 4 root e when I've subbed in the a, plus 4 root a. And I think that's right. There's quite a lot to do there, but I think that's right, Charlie. Do you agree? It's not nice, right? So now I'm going to start just evaluating this. Okay. Now let's let a tend towards 0. So I'm going to get. Well, does this 2 root e ln e do anything? What's ln e? Yeah. So this is just 2 root e. Anything else without any a's in? Minus 4 root e. Okay. And then I'm just going to think about these things with the a's in. I'm going to be adding on. I'm going to keep the limits there for the time being, Charlie, okay? 4 root a. So I'm going to think about what happens when that goes to 0. I think you can probably see it just goes to 0. And then minus the limit when 2 root a ln a goes to 0 there. So it's going to be whatever that is, yeah? Let's put a little bracket around that so we can see what we're taking the limit of. Okay? So we're almost there, I think. 2 root e take away 4 root e is negative 2 root e. When a goes to 0, what happens to 4 root a? Second.
What do you say, sorry?
So when a tends towards 0, what happens to 4 root a?
0.
So this thing equals 0, yeah? Okay. What about this? When a tends towards 0, what happens to 2 root a ln a? Well, this is one of those identities that we said right at the start. One of the results you have to remember. Something, a to the power of something, x to the power of something, then something. So this one tends towards 0. And that's why I said you've got to just remember those ones. So this thing, because it's the same form, can you see? Something, ln something, and we're letting it tend towards 0. This thing equals 0. So the answer is just negative 2 root a. Okay? Not particularly nice on that one, because you've got to do integration by parts. Okay, but that's it.